Hello students, hope all you well. Today we are going to discuss some important terms from the chapter Semiconductor Electronics. The first term is Fermi level. What is Fermi level? Fermi level can be explained as it is the highest energy level that an electron can occupy at the absolute zero temperature is known as Fermi level. It is the highest energy level in the conduction band that the electron can occupy or jump at absolute zero temperature. And the energy corresponding to Fermi level is called Fermi energy. Our next topic is p-n junction. From the word itself, we can define what is p-n junction. P-n junction is the combination of p-type semiconductor and n-type semiconductor. Okay, it's very simple. Yeah, this is the symbol for p-n junction diode. One side is positive and other side is negative. This is the symbol for p-n junction diode. Okay, let's study detail about p-n junction and the formation of p-n junction. Formation of p-n junction. Yeah, this is a diagram showing p-n junction. One side is a p-type semiconductor and other type is n-type semiconductor. In p-type semiconductor, the majority charge carriers are hole, and in n-type, the majority charge carriers are electron. And the p-type, from the p-type side, the holes drifted to n side, and from the n side, the electrons drifted to p side. So there's a diffusion or drift of electrons and holes take place, and in the depletion region, these electrons and holes gets accumulated, and both the electrons and holes gets neutralized in this region. That region is free of charge carriers because the hole and the electrons gets neutralized there. So depletion region is free of charge carriers and shows an insulating character. Again a symbol showing p-n junction, and in the left side we can see the symbol of a p-n junction diode. This talking about the movement of holes and electrons. That's we already discussed. You just read it. Now we are going to learn the most important terms related to p-n junction. The first one is depletion layer and the second one is potential layer. We already discussed what is depletion layer. At p-n junction, in the center a region is created which is free of charge carriers. This region is called depletion region. Then what is potential barrier, which is a force or a potential difference developed across the depletion layer which restricts the movement of electrons and holes. That potential is known as potential barrier. Why it called as barrier? Because which restricts the movement of electrons and holes in p-n junction. So in order to make the electrons and holes move, we want to apply voltage there. That's why we using biasing. That's why we biasing the p-n junction. Yeah, it's the detailed description of depletion layer and potential barrier. If you want to know more, you can go through this. Yeah, we already discussed about biasing. A p-n junction can be biased in three ways. First one is no biasing, without biasing. second one is forward bias, and third one is reverse bias. Then now we are going to focus on forward biasing and reverse biasing of PN junction. First one is PN junction under forward bias or forward biasing. From this diagram, it is clear what is forward biasing. You can see the P side of PN junction is connected to the positive terminal of the battery, and the N side of the PN junction is connected to negative terminal of the battery. That is forward biasing. Simply that is forward biasing. Yeah, it's already discussed what is forward biasing, but you want to know in forward biasing the current flow due to majority or minority, due to majority charge carriers. And other feature is, in forward biasing, the width of depletion layer decreases. The width of depletion layer decreases due to physical change occurs in PN junction when we applied external voltage. Okay. Next biasing is PN junction under reverse biasing. Reverse biasing. From the word itself, you can define what is reverse biasing, which is opposite of forward biasing. Yeah, from this figure you can define what is reverse biasing. The positive side of PN junction connected to negative side of battery. The N type of PN junction connected to positive side of battery. This is reverse biasing. Symbol. It's already discussed what is reverse biasing, but you want to know one of its features, that in reverse biasing the width of depletion layer increases. In reverse biasing, width of depletion layer increases, but in forward biasing the width of depletion layer decreases. Okay. A PN junction diode can be used as rectifier. Let's discuss it in our next class detailedly. That's all about reverse biasing. Next, we are going to learn two important characteristics or features of reverse biasing. The first one is reverse breakdown voltage. What is reverse breakdown voltage? From the word itself you can define what is reverse breakdown voltage. Reverse breakdown voltage is a voltage at which the current increases sharply. The current increases sharply due to a voltage. That voltage is called reverse breakdown voltage. Why it is called reverse? Because it's under reverse biasing and the flow of voltage is opposite to ordinary flow. Next one is, what is leakage current or reverse saturation current? Leakage current or reverse saturation current. First you want to know this leakage current or reverse saturation current is a feature of reverse biasing. Okay. In reverse biasing, due to the presence of minority charge carriers, a small current flows through the diode or PN junction. In reverse biasing, due to minority charge carriers, a small current flows through the diode, and this small current is called leakage current or reverse current. Okay, that's all about biasing. So all of you copy this to your notebook and study well. Thank you.